ahead and take roll. I believe Isaac said he's going to be gone. Zamian is not here. Aileen?
Here.
Nevia?
Here.
Vicente? Alyssa is not here. Isabella? Mia said that she was going to be gone. She should be in the stream. Yep, I think she is here. And Tony. All right, not bad at all. Okay. So I apologize to people on the stream. Something's weird with the resolution on the video for the Elmo right now. I will try my best to work around that. Okay, I got you, Zamian. He's also in the stream. Okay, but what I have here is a copy of our review that I sent out at the beginning of the week. Okay, so this review is actually been changed a little bit from the one that y'all got. I changed the values of each of these problems. However, we're going to go over this today and practice for our test. When is Mr. Mrzinski giving that test? Saturday? Okay, yeah. I know he's got some stuff going on that's kind of getting in the way of him coming to school. So Saturday will be when he gives this. All right. So number 1 says identify the following. Yes, sir. This? Oh, yes. This is due today, though. You know, being that the test is going to be Saturday, I'll move it back. I'll move this to Friday at midnight. How about that? I have already gotten some reviews from people through email, and if y'all sent it to me already, thank you a lot. But if you want to send it to me again, that's fine. If you want to send it to me lots of times, I'll just take the one that has the best answer. Okay? So, again, same review, just different values here. Number 1 says identify the following number. Choose all that apply. So we have -9 here, and we have some choices down here. So first of all, is this a natural number? No. Remember that natural numbers are numbers like 1, 2, 3, 4, 5, 6. They don't include negative numbers, and they don't include fractions and things like that. So, nah, not a natural number. Is it a whole number? I'm hearing different answers. Why would it not be a whole number? I don't know.
Well, you did, right? Did you put those fractions?
Yeah. I would call this a whole number. Is it an integer? Yeah. Is it rational? Yeah, because a rational number can be written as a fraction. Is it irrational? Obviously not if it's rational. Rational and irrational are mutually exclusive. You can't be both. Is it a real number? Yeah. Is it undefined? No. Okay. Let's look over here then. This one we have 1/9, 1/9. Is it a natural number? No. Is it a whole number? No. Is it an integer? No. Is it rational? Yeah. This is definitely rational. And rational again means it can be written as a fraction, which is already a fraction. Is it a real number? Yes. It is not irrational. It is not undefined. Again, real just means that it's a number that we have a concept for, which we understand what 1/9 is. Alright, so it's pretty easy. Let's take a look down here. Evaluate the following expression for the given values of the variables. Leave your answer in terms of pi, or use pi equals 3.14. So when it says leave your answer in terms of pi, that means just leave pi where it is. So you could plug in 3.14 for pi, or you could just leave pi there. Alright, so first thing we need to do here is plug in our values for our variables. And when we plug things in like that, what do we need to make sure we use? Parentheses. So if we use parentheses to do this, negative x cubed, our x is -1, so I'm going to plug in a -1 in those parentheses, cubed, plus 9 pi y, so y is 2, I'm going to put a 2 in this set of parentheses here, okay, and then plus y squared, so plus y, again 2, put that in the parentheses, squared. And now it's just a matter of simplifying this thing now that we have everything plugged in. Of course, we should follow our order of operations to do that. So, first in order of operations is parentheses, but can we do anything inside of our sets of parentheses here? Nah, not inside. We can do things on the outside though, like exponents. So we've got -1 cubed here. Now because we have parentheses around the negative and the 1, are we going to include the negative when we take the power? Yes, because the parentheses include that negative, we will include it when we take the power. So -1 times -1 times -1 is what? -1. And I'm going to keep those parentheses there because I've still got something acting on them. And then over here we've got 2 squared. What does that come out to be? 4. Good. Okay. Now we can multiply things. So the first place that I can see we can multiply is this negative on the outside of the parentheses. What does this negative do when it's on the outside of parentheses? What?
It's technically like a -1.
Yeah, it's technically like a -1, and so it multiplies in there, right? Or what I'm really trying to get at is it distributes into parentheses. So 1 times -1, I'm sorry, -1 times -1 is +1, and I'm actually going to write this over here. So we get +1 plus. Another place that we can multiply is 9 pi times 2. Well, if we're keeping this in terms of pi, then we do 9 times 2. So how many pi do we have now? 18 pi. Okay, and then +4 is just +4. Okay, now we can add and subtract. So, again, add and subtract needs like terms. So do we have any like terms? 1 and 4. So, combine those and we have 5 plus 18 pi. And again, you could plug in 3.14 at this point for pi, if you wanted to. I'll accept this though. Any questions? None? Okay. Next one. Kind of the same thing. Evaluate the following expression, expressing your answer in fraction form if needed. Be sure to use the correct order of operations. Okay. So, order of operations, again, can we do anything inside of our set of parentheses here? Nah, not really. Alright, do we have any exponents we can take? Yeah, we've got -8 cubed. Again, that negative is included in there, so this is -8 times -8 times -8. Now, I want to show you something. I don't know if the TI-84 does this. Let's see, -8 and then power 3. Okay, so if we don't have parentheses around it in here, it still includes that negative. So be careful about that. But there's our answer for that part. -512.
So on the 84 calculators, do we have to put parentheses? Or do you still recommend it?
Always put parentheses if you have it on your paper. But what I'm saying is be careful. If we had something like -2 to the third on our paper without parentheses, and we plugged it into our calculator, so -2 to the third. Now we know this is -2 times -2 times -2. I'm sorry, we know this is without parentheses 2 times 2 times 2 and then apply the negative, right? Actually, I'm going to change this to squared. So 2 times 2, then apply the negative. So it comes out to -4. Okay, I guess they fixed the problem then. -2 squared. Okay, yeah, they fixed it. Good. I know in earlier versions of this calculator, it doesn't work that way. So it ignores parentheses, basically. So just be careful when you're plugging things into a calculator. So we get -512 there. All right. And everything else drops down. Okay. So now we have multiply, and we do that from left to right. So going from left to right, the first thing we encounter is multiply. So 6 times 1, it's just 6. Okay. All right. So now we have -3 plus 6 divided by 5 minus 512. We need to divide now. Now, Hawks does weird things with when they have division and problems like this. So what do you think is the next thing we need to do? Turn it into a fraction, yeah. That's actually what Hawks wants you to do here. So what's our fraction going to look like? Okay, 6/5. Again, Hawks is a little bit weird about how it deals with these things. Okay, so now everything needs to be what? We've got add and subtract left, which we need to have like terms. And in order for these to be like terms, they all need to be what kind of numbers? Fractions. So, put this over 1, put this over 1. What do we need for our common denominator? 5, yeah. So this will now be -15/5 plus 6/5 minus, let's see, 512 times 5 is a lot, 2,560. Excuse me?
Oh, that's like if we can simplify it, or is it because that's going to make a difference?
So if we simplified, first of all, if we wanted to cross simplify, these have to be multiplied. If we were to simplify these fractions that we have right now, we'd get back down to these fractions that we have up here. Okay? So all we really want to do is combine these. So negative 15 plus 6 minus 2,560, and then put that over 5. Yeah. So we get negative 2, 5, 6, 9 over 5. Any questions? Whoops, that's not up. Any questions? Okay, moving on. Next one. We've got a union going on here. Simplify the union and or intersection. So remember, union looks like a U. Intersection is an upside down U. Kind of looks like an N for intersection. So what does U do? What does union do? Yeah, it combines two sets. It like glues them together, makes them one thing. Okay, so if we're gluing these together, we got to think about this as a start point and an end point. This one starts at negative 2 and ends at 1. This one starts at negative 1 and ends in infinity. So we want the lowest low point and the highest high point. So what is the lowest low point between the two of these? Negative 2. And then what's the highest high point? Infinity. And so, close it up. There's our union. Now for the practice, let's do an intersection as well. So intersection of these two. What does intersection tell us to get? The common numbers, yeah. So let's see what's common between these two. Okay. So this starts at negative 2, then ends at 1. This starts at negative 1, ends at infinity. The way that I would say to do this, best way, is to use a number line. So let's say 0 is here, and negative 2 is like here, and infinity is all the way over here. And negative 1 would be like here. Okay, so this one starts at negative 2 and goes to 1. So it starts at negative 2 and then goes to 1. This one starts at negative 1 and goes to infinity. So where do they overlap? What numbers? Negative 1, 0, and 1. So the start point for this line here would be what? Negative 1. And where would this end? 1. Okay, and both of those had brackets around them, so they both have brackets over here. Good. Any questions? Making sense? Okay. Let's try this one. Simplify the following expression. Assume that z is not equal to 0. Because again, if z were equal to 0, that'd be 0 to the 0 power. And do we know what 0 to the 0 is? No, we don't. So it's saying assume that it's anything but 0. All right. So if it's anything but 0, what is z to the 0 power? 1. It will always come out to be 1. So we can rewrite this and say that this is really 4 times 1. Well, what's 4 times 1? 4. Easy. Any questions? Didn't think so. Next one, simplify the following expression. So we've got -4 in parentheses to the 6th power. Remember, if it's in parentheses, do we include the negative or not? Yes, we do include it. So we've got -4 times -4 times -4 times -4 times -4 and one more -4. That's really what we have here. And if you want to make this easier on yourself, we know that -4 times -4 is what? Positive 16. So we can do that for each of these. So all we need to do now is plug in 16 times 16 times 16, or 16 cubed, into our calculator. Which gives us 4,096. I will allow you to use a calculator on this and any quiz that I give, by the way. Any questions? No? Okay. Similar. We have -3 to the 6th. Are we including the negative? No, there's no parentheses around it, so we are not including that negative. So we could just say in our calculator 3 to the 6th. So that's 729. And then apply the negative afterward. So it's -729. Any questions? None? All right. Next one. Simplify the following expression, writing your answer only with positive exponents. So what we have here is 1 over -2y, and y is being raised to the -12. Okay, so if we want to rewrite this with only positive exponents, no negative exponents, well, we've got a y to the -12th here. What does that mean is going to happen with y to the -12th? It's going to go where? To the top. Now, this is -2y to the -12th. Is that 2 going to travel with it? No, because 2 has its own power on it. Y and 2 are really separate numbers. 2 has a power 1 on it, y has a -12 on it. So y is going to be the only one that flips up to the top. And now that we've flipped it, its power doesn't have that negative on it anymore. And then -2 is just at the bottom. So we only have positive exponents. Looks like we're good. Yes, ma'am.
If I leave the 1 next to the y, is that going to make a difference?
Perfectly fine by me. Because what you're saying there is 1 times y, still the same. Technically, I have it there too. I just didn't bother to write it. Any other questions? Okay. Next one. Simplify the following expression, and it gives us 3 to the 4th power times 3. Now, what do we do with things when they have powers on them? What do we do when we multiply things with powers on them? Add them. Now, does 3 have a power on it? 1. Yes, remember that if it's not explicitly stated, it always has power 1. So if we're adding these powers together, we eventually get to 3 to the power what? 5. 3 plus 4 is 5. Good. Any questions? Y'all are doing great, by the way. And remember, everybody in the stream right now, if you have a question, just type it into the chat, and I'll get to it.
You want it making a difference?
I would accept this. if you wanted to simplify it further and actually go to 3 to the 5th, I'll accept that as well. So 3 to the 5th is 243. I'll also accept 243 as an answer. Either one is fine by me. Now, you might want to ask Mr. Mrzinski how he feels about it, because he might not feel the same way. Mostly what I want you to be able to show me here is that you know what to do with these powers. Any other questions? Okay. Next page. Simplify the following expression, writing your answer with only positive exponents. So, same deal. So right now, we have n to the negative 3 over n to the negative 2. Well, what do we need to do here? Flip it. Which ones are going to flip? Both of them are going to flip because they both have negative exponents. So this is going to flip and become n to the positive 2 over n to the positive 3. All right, well, this isn't simplified all the way. We still need to do something here. We have, good, we have things that are dividing, so when we divide things with exponents, we subtract them. So what happens here? We get n to the negative 1. Another way of looking at this, though, is we subtract these. The difference between them is 1, and it goes to the one with the highest power. So we could say that this is n to the negative 1, but then we know that that needs to flip, so we only have positive exponents, and that'll be 1 over n. Or we could say, okay, the difference between 2 and 3 is 1. The one that had the larger exponent was on the bottom, so it goes to the one on the bottom. But the takeaway here is that the answer is 1 over n. Very good. Any questions? Y'all still good? Okay. Next one, simplify the following expression. Only use positive exponents. So we've got x to the negative 7th times x to the 4th divided by x to the negative 5th. So what is the first thing that we should do here? Flip. Yeah, I'd say so. You could multiply x to the negative 7th and x to the positive 4th. You still have to flip eventually. I'd go ahead and flip first. So x to the negative 7th, that's going to go to the bottom. It'll just be x to the 7th. X to the negative 5th is going to flip to the top. And again, be positive 5 now. And we still have x to the positive 4th up here. Okay. Now what should we do? Do what? Yes, because we're multiplying them. Good. So x to the 5th times x to the 4th, we add those exponents and we get x to the what? X to the 9th over x to the 7th. And one last step. What do we do now? Subtract. So 9 minus 7, the higher one's on top. We get x to the what? X to the 2nd over 1, or just x to the 2nd. Excellent. What questions do we have? None? Okay. Next, use the properties of exponents to simplify the following expression. Write your answer with only positive exponents. Okay. So we've got a lot of negative exponents in this one. Now again, I suggest that you use your negative exponents first. So let's see what we get. Well, first of all, we've got a negative exponent on the outside of this set of parentheses here. So we've got 3 to the third, x to the negative third, y to the negative fifth, all raised to the negative second power. So we should probably go ahead and raise all of these to the negative second. So what do we do when we raise a power to a new power? Multiply. So 3 to the positive 3 is now going to be 3 to the negative what? 6. X to the negative 3 raised to the raised to the negative 2. That's going to be x to the what? Positive 6. And then y to the negative fifth raised to the negative second is y to the positive 10th. And then I'm just going to say we still have 3 to the negative second up here. All right. So now let's go ahead and take care of our negative exponents. We've only got 2 of them. So again, they're going to flip. So 3 to the negative 6, that's going to flip to the top and become just 3 to the positive 6. 3 to the negative 2 is going to flip down to the bottom and be 3 to the positive 2. And we still have x to the 6th, y to the 10th here. Okay. Now, we could, at this point, do 3 to the 6th and 3 to the 2nd, and then divide. But remember, we have exponents. So what do we do when we divide things that have exponents on them? Subtract. So we get, let's see, 6 minus 2 leaves us with 3 to the what? Okay? And is it on top or bottom? Top, because that's the one that had the bigger exponent. I'll slide this up for y'all on YouTube so that you can see it. So we have 3 to the 4th on top, and then x to the 6th, y to the 10th down here. And let's go ahead and figure out what 3 to the 4th is. So 3 times 3 is 9. 9 times 9 is 81. So we have 81 over x to the 6th, y to the 10th. Excellent. Any questions? Okay. Next one. Simplify the following expression, again writing your answer with only positive exponents. So we're raising a power to a power here. What are we going to do with those 2 powers? Multiply. So what's negative 5 times negative 3? Yep. So this comes out to be x to the positive 15th. Again, negative 5 times negative 3 is positive 15. And that's it for that one. Any questions? All right. Last one. No, that's hard to see. This is negative 3 x squared all over y to the negative 3. And then this whole fraction is raised to the 3rd power. Okay. Yeah, positive 3 power. So looking inside of the parentheses, is there anything that we can do? Well, look again. Yes. This bottom part here, y to the negative 3, we can flip that up to the top. So we will have negative 3 x to the 2nd, y to the 3rd, and it's over 1, so we don't really need that over 1 part, to the 3rd. Okay? So now what do we need to do? Yes, so we need to raise everything to the third. I'm not getting on you for anything. Powers don't distribute.
Oh, God.
And trust me, it looks like they do. It really does look like they do, because everything is getting raised to the third power. And so it's perfectly fine for you to say that right now. I'm not getting on to you for anything. But later, we're going to see cases where if we try to just distribute that power, it doesn't work. So I want to tell y'all right now, don't get used to the thought of distributing powers. You should start right now thinking, okay, they don't really do that. Just for this one, it kind of looks like they do. Remember, what's really happening here is we're writing this out 3 times. And so this 3 gets multiplied by itself 3 times, the x squared gets multiplied by itself 3 times, the y to the cube gets multiplied by itself 3 times. Okay? But you're right, we are going to raise everything to the third power. So this will be negative 3 to the third, and then x to the what? 6, and y to the 9th. And there's one more thing we got to do. Now, I'm going to put parentheses back around this, because this was in parentheses to start with, and we raised it to a power. I want to make sure it still has parentheses around it, because we want to include that negative like it was before. So, negative 3 times negative 3 times negative 3 is what? Negative 27. Okay? Then we have x to the 6th, y to the 9th. And I believe that's all we can do with that one. So any questions? None? No questions. All right. Cool. So, Friday, for my class, we will have a quiz. And the quiz is going to be what you see on this review. I will also add in 1 or 2 questions about radicals, our roots. Okay? It's not going to be the majority. The majority is going to be this stuff here that we have on our review. But there are going to be 1 or 2 questions about radicals. So, remember, study for Friday, study for Saturday. This review should help you for both of them. Okay? Other than that, though, that's all I have for today. So I will see you on Friday. And remember, I am extending the deadline for the review. Since Mr. Merzinski is giving his test on Saturday, I'm extending mine to Friday at midnight. And I'll send an email reminder saying that as well. All right. I will see y'all on Friday. You have a question?
So the quiz will be like an email like last time?
Yes, the quiz will be an email like last time. Yeah, so I can just send it to you, and you can turn it in.
Okay. If you already turned in your review sheet, and like say you want to make a change or something, can you send it again?
Absolutely you can. I will take the better of the 2 scores.